see that object. So what I am going to do first, escape speed ve equal to root 2gm upon r. So 2g 6.67 into 10 to the power minus 11 11 एक extra आ गया into it is nothing into mass 1.3 into 10 to the power 33 kg. कैलकुलेशन को थोड़ा और अच्छा बनाने के लिए से 1.1 कर देता हूँ. देखो अल्टीमेटली आई विल गो फॉर रफ कैलकुलेशन, अप्रॉक्सीमेट कैलकुलेशन, तो आई डोंट माइंड डूइंग दैट. 1.1 इंटू 10 टू द पावर 6. पहली चीज़ मैं ये बता दूँ, इट इज़ सन सोलर मास, जो सन का मास है वो होता है 10 टू द पावर 30 kg के ऑर्डर का, एंड इट इज़ 33 मीन्स 1000 टाइम्स मोर मैसिव. वेल एक्चुअली जो ब्लैक होल्स होते हैं दे आर मोस्टली 10 टाइम्स मैसिव देन द सन. सो इट इज़ एक्सट्रीमली मैसिव बॉडी इट इज़, और इसका रेडियस अप्रॉक्सीमेटली अर्थ के रेडियस के ऑर्डर का. सो ऑलराइट, सो इफ़ वी solve it, 11 6 approximately 11 6, so it will get cancelled 6 times, and 6 2s are 12. 12 into 13 is this time we can multiply 12 into 13, it is 130 156. So 156 15 point no 156, yeah, 15.6 into 10 to the power minus 11 plus 33 minus 6 and whole root. If it would be 16, then the answer would be 4. So we can approximate it to maybe 3.9 into 10 to the power, oh, still it is inside. So 10 to the power 16, it is 10 to the power 16. Yeah, of course. So its root means half of this power. So 3.9 into 10 to the power 8 meter per second, which is greater than speed of light. It means speed of light cannot escape from this. So light cannot escape from it. So we can't see that object. So first thing was to calculate its escape speed, and second thing that that answer is so dramatic. Its escape speed is so large so that even light cannot escape from it. And this is what the theory of black holes is all about. Okay, two stars each of mass, see, these are two approaching each other. Approaching means they are being pushed by some other agency. When they are 10 to the power 9 kilometer away, this is the situation for that. Their speeds are negligible. Actually, now almost they are at rest. With which speed both will collide. Now onward they will be being pulled toward each other, and finally they will get collided. Each star, radius of each star is this. So when they will collide, distance between their centers will be 2 into 10 to the power 4 kilometer. Okay, so what is the main scenario in this question is kinetic energy initial plus potential energy initial is equal to kinetic energy final plus potential energy final. And that's true, it is total kinetic energy, means kinetic energy of this plus kind of. So initially their speeds are negligible, so zero kinetic energy, but there is potential energy of the system G. Both are having same mass, so right now I'm using just symbol, and huge distance between them, I'm writing it small r. Final kinetic energy is half mv square plus half mv square of both particles, of both bodies, minus g m 2 times m upon distance between their separation. I'm writing it 2 into radius. Next step, So it will be mv square. 1m will throughout get cancelled, so I can take it here. Gm, okay, right now I'm writing m square upon 2r minus gm square upon small r is this. This this is small r. This is twice of this is yeah, this is big R, is equal to mv square, half of 1. 1 power will get cancelled. Now we will put the value 6.67 into 10 to the power minus 11 into m2 into 10 to the power 30 upon 2 into distance between them. 10 to the power 4 kilometer means 10 to the power 7 meter minus same 6.67 into 10 to the power minus 11 into 2 into 10 to the power 30 and upon 10 to the power 9, and it is kilometer, so convert it into meter, so it will be 10 to the power 12. Now see, in the denominator here it is 10 to the power 7, here 10 to the power 12. So if, let us suppose, its answer is 1, then its answer will be 0.0001. So we can neglect this. In approximate calculation, you can ignore this value. Okay, why? Because it will go to the 1 millionth, not 1 millionth, but yeah, I mean 10 to the power 5th, 1 by 10 to the power 5th part of whatever be the value of this. So we can neglect this. In the exam, you can, what you can do? You can't do, you have to write something here. But practically, it will be a negligible value. We can write it is a negligible in comparison to first value. It is a very huge value, but in comparison with this value, it is negligible in comparison with first value. So that's all. V is root of this quantity. 2 will get cancelled. So it is minus 11 plus 30 minus 7. 10 to the power 12 it is. 6.67, what is the root of that? Just little bit above, because we can write it 667 upon 100. 667 is close to 625. 625 has root 25 and 100 is 10. So it will be 2.5, but it is not 625. It is 667, so little bit more than that. So 25 point, oh sorry, 2.5, so 2 point, approximately 2.5 something, 2.6 by rounding off, into 10 to the power, what is it? 10 to the power, it is 18, 30 minus 18, that is 12. So root of 12 is 6 meter per second. So it is a direct question. What is the potential energy due to gravity of Earth on satellite of height this? Oh, its mass is not given. So let its mass of satellite be 500 kg. Okay, so now potential energy will be minus Gmm upon R. That is minus Gmm upon R plus H minus 6.67. It is a traditional numerical. Mass of Earth 6 into 10 to the power 24. Mass of satellite 5 into 10 to the power 2, 500. So R plus H. R plus H अलग से निकाल लेते हैं. R is 6.4 into 10 to the power 6 और ये हो जाएगा प्लस 3.6, no 36 into 10 to the power 6, 3 0 और किलोमीटर के 3 0. So it will be 42.4 into 10 to the power 6. So once again, approximate calculation, 6 are 30. Actually, it is close to 7. 6 7s are 42. Here we have 42. So they will approximately get cancelled, but it is not exactly 7. So we will not get 42 here, maybe 41. So 41 upon 42 is something about 0.9, and 9 fives are 45, so it will be somewhere around 4.5 into 10 to the power minus 11 plus 24 plus 2 minus 6. So 26 minus 6 is 29. So it will be minus 4.5 into 10 to the power 9 joule. So another amazing type of question. A star 2.5 times massive than sun. It means mass is equal to 2.5 mass of the sun, 2 into 10 to the power 30. So it is 5 into 10 to the power 30 kg. Collapse to a size. Okay, such an event also happen in the space when star get contracted to form white dwarf, or actually red giant and then white dwarf, or neutron star, or black hole. These are different stages for different type of stars. Anyway, right now it is not in our discussion. Of size 12 kilometer, very small. Chandigarh city, yeah, size of Chandigarh city, that much. Rotates with the speed. Okay, it is spinning. So its radius is 1.2 into 10 to the power 3. It is better to use. Sorry, 12. It is 12 kilometers or 12. 1.2, nahi, 12 it is meter. Rotates with speed. This is actually frequency of rotation per second. So just forget about this right now. Will an object placed an equator remain stuck to its surface? Actually, they are talking about, just imagine if you are sitting on a merry-go-round, you are being pulled away. So you need some, you hold something and you have to apply some force this way. You require centripetal force to be stationary. Otherwise, you will be thrown out. In the same way, this star is rotating. So if some object is there, there is acceleration due to gravity. But is that acceleration due to gravity, and due to that the gravitational force is enough to give it centripetal force? So let's see. First, what we will do, we'll find acceleration due to gravity. Means इसका acceleration due to gravity से खींच रहा होगा, and when there is acceleration due to gravity, there is force, gravitational force, जिसे हम weight कह देते हैं. It is gravitational force. So we'll check this entire question on the basis of centripetal acceleration and acceleration due to gravity. अगर acceleration due to gravity ज़्यादा हुआ, तो then that object will be stuck with that planet, that star, and if it would be less, मतलब ये actually है नहीं वहाँ पे, ये required है, ये इतने का acceleration, centripetal acceleration required है वहाँ. So first side we will find it for g, other side for centripetal acceleration, and we will see कि g से उतना centripetal acceleration मिल पाएगा या नहीं मिल पाएगा. So we know g equal to gm upon r square. So g is 6.67 into 10 to the power minus 11, m 5 into 10 to the power 30, and upon r square. R is this 12. So 12 into 12 into 10 to the power 3, so it will be 6 square. 10 to the power 3 का स्क्वायर करेंगे तो 10 to the power 6 हो जाएगा. 9 नहीं हो जाएगा, 3 का स्क्वायर नहीं हो, 10 to the power 3 का स्क्वायर है, तो पावर पे पावर होती है, पावर मल्टीप्लाई हो जाती है. Now, is there any approximate calculation? I do have. Yeah, of course, I have. If we multiply both of them, 7 5s are 35, but little less, 33. So it will be 33 upon 12 12s, we know it is 144. So if we know something, no need to do approximate calculation then. But to save, it is just in order to save the time. So okay, now once again approximate calculation. It is close to 150. It is something like, okay, I will do it later on. Right now I'm writing it as it is, into 10 to the power 13, isn't it? Yeah, 13. I'm donating a 0 here. It is 330 into 10 to the power 12 upon 144 2za, 144 2za. So it will be something around 2.2 into 10 to the power 12 meter per second square. this much acceleration due to gravity that object has. And let's see how much is required. So there is speed. They have used the term speed, and generally it is called speed, rotational speed, but it is not, neither it is speed nor it is angular speed, it is just the frequency, 1.2 rps. So what will be the angular velocity? 2 pi nu, that is 2 pi. I want to put pi as pi only, and nu is 1.2. I think I have done something wrong. 1.2 rotation per second is too less. Let me check it. Yeah, it is that. So it is not difficult. Um, it will have very less centripetal acceleration, required centripetal acceleration. Actually, here we have to write required. Oh my god, that was really, really shocking. Required centripetal acceleration for this kind of rotation. So we know it is r omega square. So radius is 12 kilometers, that is 12 into 10 to the power 3 omega square, square of this quantity, 4 pi square. 1.2 square means, okay, 144. It will look like this. And see, once again another approximation, pi square is close to 10, so we can write it 12 into 4 into 1.44 into 10 to the power 4, 3 power here and 1 power here. So we will multiply it. So how much it is? It is close to 1.5. 1.54 is a 6, and 12 6 is a 72, approximately 7 into 10 to the power 4. So it is much smaller. It is much smaller. So this centripetal acceleration can be provided by this centripetal acceleration can be provided by acceleration due to gravity. A part of it will contribute to give that body centripetal acceleration, so it will remain stuck. Now the sun's pull. Okay, this question, first I want to give disclaimer, is not directly included or even included in the syllabus, but this type of question can be asked, and don't think about just the syllabus. I found it very interesting one, and we should know about it. Sun's pull is greater than moon's pull, of course, on Earth. Of course, if we want to calculate, or I will upload another video in which I will give you the values that how much force sun exerts on Earth than moon exerts on Earth. So sun's pull is greater than moon's pull. We know that. However, the tidal effect of moon's pull is greater than tidal effect of sun. Why? The answer is gravitational tidal force does not follow the law of gravitation with inverse square relation. Gravitational force is inversely proportional to r square, whereas tidal force is inversely proportional to cube of distance, approximately. It is not exact thing. And since distance of moon with earth is less than distance of sun with earth, so because of cube, the tidal force, because of this here also, but okay, it depends upon mass also, so I'm not writing it here, but here, so that is why tidal force of moon is greater than tidal force of sun. on Earth. But these things we haven't studied in this chapter. So in the scenario of this chapter, how we are going to proceed it is something like this. This is Earth, and there is an oblate that is sidewise pull due to gravitation. So we can assume another small object here. So there is an additional object we can assume, and that is why this additional factor comes here. It is just because of some higher powers of that this additional factor which is being included here. So I'm not going into derivation of it, but there is some non-linearity in this function now. The force which is being exerted by moon or being exerted by sun, so there is a slight non-linearity, but that is quite enough to produce this large difference between tidal force. So you can understand that, and if require, if you people would ask, then I can upload its derivation also, which is not required, but of course if you are interested, I can upload its derivation also. Next, Halley's Comet orbit the Sun in highly elliptical orbit. Does comet have actually, if this is Sun, so this is the orbit of Halley's Comet. Oh, highly elliptical. So other orbits are something like this. They are elliptical also, but Halley's Comet is highly elliptical. So does comet have constant linear speed? Answer is no. First one, no. Close to Sun, V is high. Far from Sun, V is low. Angular speed, we know that no, since omega equal to V by R. And now same thing. Angular momentum, I'm not going into it right now. D, kinetic energy, no, as V is not constant, as A and V. Velocity is not constant, so that is why. Potential energy, no, as D. Kinetic energy is not constant. F, total energy, yes, it is constant, because if it increases, it decreases, and vice versa, but total energy remains constant. What about this angular momentum? So angular momentum remains constant, because we know that tau equal to dl by dt. Torque acting on a rotating or body undergoing rotational motion or revolution is equal to rate of change of its angular momentum. But there is no external torque. In this situation, there is no external torque. Whatever there is, the force, gravitational force, which gives it a torque, but that is its internal torque, not external. Like right now, if I push it, I am providing it external torque, and I move my hand like this. These are my internal torques. I am providing internal torques. But this one internal torque, it is not a satisfactory answer to that. Internal torque is something like same system, Halley's Comet and the Sun. So there is no external agency which is providing both of them a force so that it could move. So tau is 0, so dl by dt is 0, so that is why L is constant. Now here is a very interesting one, and no calculation, just a direct question. So the question is, in the following 2-point PQ, here is P, there is Q. Choose the correct direction of gravitational intensity of hemispherical shell. So remember, if it would be a complete shell, for complete shell, means hollow sphere, gravitational intensity, which I refer as EG, actually I use the term EG. EG is 0. There's no gravitational intensity inside the shell because there is no mass inside it. So now if we just do it just concept wise, if I divide it into two parts, so we can say that at this point, because E is 0, so at any of this diametrical point, if there is a gravitational intensity right now, so in the same way there will be gravitational intensity. There is also, there is also, and they both must cancel each other in order to give zero intensity inside. I'm not writing its answer, I'm just stating it, I'm just telling you the answer. So you can write its answer as taking complete spherical shell, and inside the spherical shell gravitational field intensity is 0. Now taking a diametrical plane, it is a diametrical plane passing through a diametrical plane, and each diametrical plane of hemisphere will have direction of gravitational field intensity in opposite direction. यहाँ जो भी डायरेक्शन होगी उसकी अपोजिट डायरेक्शन दूसरे वाले में होनी चाहिए, so that they could cancel each other in order to give zero intensity. Now on the basis of that, we can say if there is any point, it can't have intensity in this way, otherwise it cannot be cancelled by this. It must have intensity directed this way, so that it could be cancelled by this. This would be cancelled by this, and so on. Now keeping this thing in mind, we can say that for this point P, gravitational field intensity, one more thing, gravitational field intensity would act toward the object, so its direction is toward this. Alright, in the following 2 point PQ, choose the correct direction of gravitational intensity. Okay, so here if we consider complete hollow sphere, what is this happening? Complete hollow spherical shell. Then gravitational field intensity inside it is 0. So if we divide it into two parts, then at any point on diameter of 1 will have gravitational field intensity in opposite direction on that of other, so that both will get cancelled, so that gravitational field intensity will become 0 if we combine both of them. So in this way, the best possibility is just opposite directions, linearly opposite direction, not angularly. Otherwise there will be, if this would be direction and we cancel it some by this one, then there will be some other points also, then it have to go like this for this side and this way on other side. But it means that gravitational intensity on this side is more, this side is more. What about these two sides? That is not defined properly. The best possibility is this. Now we can say that there is a mirror image along the diameter. So in this way, we can say that for first diagram, gravitational field intensity cannot be like this for this shell, or like this. First thing, gravitational field intensity always directed toward the body. It has to go like this. And if we enclose it with similar, then that will also have in opposite direction. Both will get cancelled, and then this thing will come true. So for first, direction of gravitational field intensity must be along C. What about this? Here also, no matter how it is shifted from the center or anywhere on this diametrical plane, it is for sure that still, if we enclose it with similar kind of hemispherical shell onto it, So in order to compensate, in order to make it zero here, this or this cannot be used. Only this direction can be cancelled by just the opposite direction created by this shell. So H is the correct answer. So the escape speed of a projectile on Earth, we know this. A body is projected with the speed thrice that of escape speed. What is the speed of projectile far off? Generally, when we derive escape speed expression, what we used to do, we assume that here it will be exhausted. So its kinetic energy will end up here, and its potential energy also. So but this time, so it is VE minimum speed we give it, so that it could reach till this. But if we could give it more than this, it will be able to go far off. Far off means away from the gravitation of Earth. So one thing is for sure, that this equation will be applicable. This is the first part. Second part, what is the kinetic energy? Half m v square. Instead of v square, I will write 3ve. Thrice the escape speed minus g mm upon r equal to, there will be some kinetic energy, and this is what we have to calculate, final velocity, final speed instead. Now at that level, it has crossed that level, so now it is no longer in contact with Earth. So gravitational potential energy with respect to Earth of this object is 0 now. So next step, just cancelling m, 1 by 2 9 ve square minus g m upon r equal to half v square. This 2 is 1 by 2 is also not looking fine. I'm multiplying entire equation by 2. 9 v, many teachers say that you have to write this thing multiplying this. Well, if your teacher says that, that's okay, go for it, write that thing. I don't recommend that. Okay, now VE, we know VE is root 2 gm upon r. If you don't know, watch the video I have made for escape speed. Otherwise, this numerical won't work for you. Squaring, if we square that, so root will be removed, so it will be 2 gm upon r minus 2 gm upon r equal to v square. 18, and it will be, what will be 18 minus 2, that is 16. I'm doing it directly, you can also do it directly, by r equal to v square. So v is equal to root of 16 gm upon r. Now see the trick. Root 8, no, this is not that what I was looking for. Anyway, into 2 gm upon r, and this is VE. So root 8 into VE. That is why they have given value of VE. So root 8, what is the value of root 8? Once again, my approximation, oh no, not required. Root 8 means 2 root 2, and root 2 is 1.414 into 2, so it is 2.82. 1.414 actually. 8 point. I'm going to, no approximation this time. I'm going on to so much accuracy, kilometer per second. And multiply this, you will get the answer. Do I have any other approximation here? Yeah, of course. Approximate it to 3, approximate it to 11. 11 3s are 33, little less than 33, 32.9 kilometer per second.